Bismillahirrahmanirrahim. Welcome back. So last time we had discussed the planar linear autonomous system, and we had decided that planar linear autonomous system looks something like x bar to be equal to a times x, where A was a 2 by 2 matrix and X was a column vector and X prime was vector of derivatives. So we had decided that planar linear autonomous system looks like this, or maybe in general we could write X bar y X prime y prime to be equal to some matrix A B C D times XY. Or maybe we can say that this same system could be written in this form, cx plus dy. Now we also know that from the one-dimensional theory that equilibrium points equilibrium points our equilibrium solutions, our stationary solutions, our fixed points can be found by solving x dot to be 0. So this implies that we need to solve this system. And we all know that for solving such systems we need to have help from linear algebra. And now we will be moving towards linear algebra and ask linear algebra what does it say about the solutions of such systems ax to be 0, where A is a 2 by 2 matrix and X is a column vector 2 by 1. So it turns out that the linear algebra tells that 0 comma 0 is always solution to this system. As you know that you can put here 0 0, and with any A you multiply you get 0 0. Don't forget that this is also column vector, so that's 0. So what does this mean? This means that 0 0 is always a equilibrium point. But here is an interesting theorem that tells more about it, which can be proved with the help of linear algebra, and it's a consequence of linear algebra in fact. So the idea is going to be very interesting. We know that if the determinant of this system is non-zero, then this system will have a unique solution. And indeed, the unique solution has to be this 0 0, because it's the only solution we already know. If the system has only one solution and we already know one solution, so this is going to be the solution. If determinant of A is 0 is non-zero, let me correct myself. If determinant of A is non-zero, then the system has only unique solution, and the unique solution is going to be this one. What if the determinant of A is 0? What will happen if determinant of A is 0? Well, in this case there will be infinitely many solutions. In fact, we will have a line of equilibrium points. So with this information I'll state without proof a theorem that is very interesting and useful in the upcoming theories. So let me state the theorem. So here is the theorem. The theorem says that the planar system ax to be equal to x prime or x prime to be equal to x prime has number one has a unique equilibrium point or maybe equilibrium solution, we can say, or sometimes fixed point or stationary solution. Unique equilibrium point, if unique equilibrium point 0 0, so this is going to be x0 and y0 if determinant of a is, as already discussed, non-zero. Secondly, uh, so the planar system ax equal to x prime to be ax has a unique equilibrium point 0 0 if determinant of a is not 0, and it will have a line of equilibrium points if determinant of a is 0. So in this case we assume that a itself is non-zero. So a is non-zero but determinant of a is 0. So for this case, so there are two things. One thing is unique equilibrium points when determinant of a is non-zero. A line of equilibrium points if determinant of a is 0. And both of the cases 0 0 will always be there. So in this case 0 0 is the only solution that we will obtain, and in this case along with 0 0 we will be having more other solutions. So this is all about for the planar system x prime to be equal to ax. With this we will move ahead. This theorem will be very useful in the coming lectures.